So this is the formula for constructing a confidence interval for the difference of two population proportions. We're not going to worry about these formulas as much as we are how to do this using StatCrunch. Although I do want to point something out to you. When StatCrunch computed this standard error, it assumes that P of teens equals P of adults. And so this standard error is going to be what's called a pooled standard error. When we do confidence intervals, we don't make that assumption. And so the standard error formula is going to look a little bit different. That's just going on in the background. You don't have to worry about that because StatCrunch does all that lifting for you. We are going to construct confidence intervals for the difference of two proportions. The model requirements, which are listed right here, are the same. So let's do this example here. In a recent Harris survey, respondents were asked, how acceptable is divorce to you personally? Among 970 individuals who considered themselves religious, 834 considered divorce to be acceptable. Among 1,285 individuals who did not consider themselves to be religious, 1,157 considered divorce to be acceptable. We're going to construct and interpret a 95% confidence interval for the difference in the two proportions. First, let's get the sample statistics, P hat for the religious folks. In other words, what sample proportion of religious folks considered divorce to be acceptable? That's 834 out of 970. And I'm getting 0.860. And the P hat not religious, how many considered divorce to be acceptable is 1,157 out of 1,285. I'm getting 0.900. And so what we want to do is construct a confidence interval for the difference in the two proportions. So we go through the three model requirements. Thing one, is the data obtained independently? Yes, the religious folks were obtained independent of the non-religious folks. The response variable is qualitative with two outcomes. Either you have the characteristic that you consider divorce to be acceptable or you don't. And then the second model requirement is that n times p hat 1 minus p hat has to be at least 10 for each of the two samples. So let's say that for the religious folks, that would be 970 times 0.860 times 1 minus 0.860. So 970 times 0.860 times 0.14, I'm getting 116.8, which is at least 10. If we computed n times p hat times 1 minus p hat for the non-religious, it also would be at least 10. So that's satisfied. And then the last requirement is the sample size is no more than 5% of the population size. I don't know how many religious folks there are out there, but I'm sure it's in excess of 1 million. 5% of 1 million is 50,000. We're good there. Same deal for the non-religious folks. And so our model requirements are satisfied. And so now we can construct the confidence interval using StatCrunch. Here's what we do. You're going to go stat, proportion stats, to sample with summary. Because again, we have summarized data. So I'm going to say sample 1 is my non-religious. 1157 out of 1285. 1157 out of 1285, my non-religious. And then sample 2 is my religious. 834 out of 970. 834 out of 970. And now under perform, we're doing a confidence interval. It's always going to do P1 minus P2. Always. So that's why it's important to know which one goes into sample 1 and which is in sample 2. And we're doing a 95% confidence interval. So click compute, and boom, there are your results. Now when we get into interpreting, I think it'll make more sense to you why I did it the way I did. So we are 95% confident the proportion of non-religious individuals who believe divorce is acceptable is between 0.013 and 0.068 higher than religious individuals. Having these be positive quantities makes it easier to interpret. That's why I wanted the higher proportion to be in sample 1. Because if I flip-flopped them, I'd have negative values here, and that makes it more challenging to interpret.